Hey DZone, we're here at All Things Open in Raleigh, 2015. And I'm here with Andy Oliver from Mammoth Data, the second interview of the day. And we're going to talk about big data, how big data is solving problems, and what kinds of problems they're solving right now. Can you introduce yourself?
Yeah, so I'm Andrew Oliver. I'm the president of Mammoth Data. I'm also the founder. And I founded the company after putting out an open source project in the .com bomb called POI, which is a port of Microsoft's file formats to Java. That led me into sort of open source and moving to, I ended up in a company called JBoss that got bought by a company here called Red Hat. And after that, I started a consulting company, mainly helping other people out. Over time, I found that we were moving. The company was originally called Open Software Integrators. We were moving to a more everything about data and new data architectures. We were using more of these new data architecture databases like MongoDB, like Couchbase, Cassandra, etc., and starting to use a lot of Hadoop. And I was like, wow, this is the most important stuff we're doing. So within the last 2 years, we transitioned to focusing on what we call new data architectures. And part of the reason I don't say that is I don't like to say big data because people are like, oh, I don't have big data, I only have, and then when we dig into it, we're like, wow, you actually have quite a bit more data than you realized. These technologies aren't just for big data, they're for complex data, they're for semi-structured data and what have you, and new use cases. So we help companies go and do data strategy, data architecture, and the initial implementation or that high-end implementation of this new technology so that they can make better data-driven and algorithmic and move to real-time data-driven companies. So that's sort of the vision. That's why we're Mammoth Data.
Not big data, but Mammoth Data.
Mammoth, our data is bigger.
Even bigger than big data.
Yeah.
Well, to me, as I used to be a DBA, and to me, big data just means any data that you have to worry about with respect to some quantity. It doesn't have to be the number of bytes, it doesn't have to be the incoming speed. It could be any of those, could be the complexity, any of those things. As long as you have to worry about it, you have to start thinking about the data architecture. You have to say, maybe I don't need a node-to-node table here. Maybe I should think about a totally different data structure at this point. And that's the thing, is that we need to think about data as a first-order entity. Think about data as an artifact. Think of not a side effect. A lot of times people have said, okay, I make widgets and yeah, data happens, but it's a side effect. No, we need to think of that as a first-order entity. We need to think about the data, and we need to think about the use cases for the data, which means we need to think about our company's process also as a first-order artifact. And when we do that, we can make our company more adaptable. We can make able to find new opportunities and more flexible. And that's really, really important in highly regulated or competitive environments. If you're neither of those things, well, you probably run a mainframe. But even some of the companies that used to run mainframes, I was just at the Couchbase conference, and Marriott mentioned that they just went from mainframe to Couchbase so that they could move everything to the cloud. And why? Because they're building too many hotels, and it didn't really, their architecture didn't scale and what have you, so they needed the flexibility. This sort of change is bubbling through the industry, and the people who really get it and move to this data-driven decision-making and move to real-time are the ones that are going to be the most competitive and are the ones that are going to best be able to handle complex regulatory environments. Right, and the real-time thing I've heard you talk about a couple times before, and this is something that our audience is interested in as well. People are, in our last big data survey, they're encountering more kinds of real-time data, and they're using tools like maybe Storm or maybe Spark to try to handle incoming streaming data more quickly. Can you talk a little bit about the new types of problems that you run into when you're trying to do this, both from the technical perspective and also from the business process perspective?
Yeah, and let me give you an example. So one of the things that we see, especially in financial services, a lot of them still do things like anti-money laundering in batch. But if you're one of the larger banks and you've got the transactions coming in, there's no reason you have to do it in batch. You've got both the market segments of those businesses, the geography of those businesses, the types of those businesses. You should be able to react to see when they go over thresholds and mark those accounts as, okay, maybe Walter White bought the ice cream parlor or the car wash kind of thing, and go ahead and start flagging either the business or transactions for further investigation. You shouldn't really have to do that at day end or quarter end or whatever. That should be something that just happens as you go. So this sort of piecemealing of the analysis that we typically do in batch means doing things like using Spark streaming, or if you need CEP or real time, or you need low latency rather than using something like Storm or Apex is a new project. Using one of those, handling the events as they come in, usually using something like a columnar database like Cassandra or HBase or what have you, storing those thresholds in addition to the data. Usually we put an event queue in front of it, storing those thresholds and saying, okay, here's a hash mark, here's another suspicious transaction or whatever our threshold is for that data. And that threshold might be something like, okay, it's December, it's 30 degrees out, why is this ice cream parlor selling in an unusual amount of the same amount that they sold in June? That doesn't make sense. It's cold.
Right.
So instead of doing that as a batch process, we just do it a little bit at a time as a real-time process. But this involves not just data systems. So this is the important thing people have to understand. This change can't happen overnight, because not only do I have to handle real-time, I could maybe do this overnight for, well, not overnight, but not overnight for anti-money laundering, but for an entire business operation. I can't do this overnight, because if I'm that ice cream parlor and suddenly the temperature drops, I'm going to lower my supply. This is just-in-time inventory and what have you. I'm going to lower my order based on public information, the market, the weather, what have you. And I need to be able to tell my supplier, hey, don't deliver as much stuff today. I have to have a business relationship that lets me do that. And that bubbles throughout the organization. It bubbles how we manage ourselves, what our process is, our relationships with our suppliers, our relationships with our customers. And so it's a change that's not happening overnight, because it can't just be something the IT department does and says, hey, guess what? We've got real-time processing systems. So we're not using them. So it's a really important change, and the technology goes beyond the ways that people traditionally think of it. It's not just for call data records or transactions coming in for complex event processing or trading or whatever. It's for everything. In the end, real time will eat most of batch processing. We'll still do it for historical trends and things like that when we're going and exploring and finding new things. But for our day-to-day operations, there really isn't a reason to do things in batch in the end.
Because the reality, you're saying, once you're talking about data as first-class citizen, then a mismatch between the data processing rate is going to occur if the data processing is happening in batch, when in business reality it's just happening in a stream.
Yeah. I mean, we made these batch systems because we started out with the IT industry processing paper. I mean, if you think of what Unix, some of the first Unix tools there for trough and things like typesetting and what have you. I haven't used a printer in over a year. I don't even know how to connect to mine anymore. I haven't used a printer in over a year, but we had these systems that were intended to help us process paperwork and do this paper process more efficiently.
Right.
But no one's gone back and said, why do we have a web page? Why is it a page?
Right.
I've never going to
JavaScript developers are like, I have to deal with the fact that it's basically a page. That's terrible. Let me make a new framework that makes it really object-oriented.
Yeah, I don't want to deal with a page.
Yeah.
I mean, the entire concept. So dealing with this this change, though, when we think about how business happens, the market in China crashes not on your schedule. So you had your big sell stuff in China initiative that you were planning this quarter. You can't really wait till the end of the quarter to do your quarterly planning session, your QBR, and say, okay, we're going to stop buying as much stuff this quarter, and it's too late. You're going to make that decision now. Why do it out of band? Why not make every decision that way? And why not make these decisions based on data? Studies have been coming out saying, look, people make a lot of dumb decisions. they're afraid of computers making decisions, but statistically, when we use an algorithm to make a decision, we usually do a better job with the algorithm than if people make a decision. And when we do it over 1,000 decisions, we are better off with the algorithm. And there was a great thing that came out recently about CEOs picking the higher risk decisions or having a bias towards making those, when statistically, if we made over time in a big enough company, when you make enough of those decisions, the algorithm looking at the risk and making a risk-oriented decision will make a better decision than will the meat computers in our head.
Right.
So it's really whether you see yourself as a circuit in the machine or whether you see yourself as the operator at the keyboard. We're not talking about replacing people. Excuse me. We're talking about computer-aided decision-making, where the computers do a lot of the day-to-day processing, and humans audit this and say, okay, look, it made all these decisions, here's why. Do we need to tune the algorithm? Do we need to change the process? Do we need to tweak a parameter?
Right. So that means, again, you're paying constant attention, you're updating your model all the time based on the data that's coming in, based on the changing world. And that's, finance I can see is a really good example of this, right? Finance is reflecting millions and millions of decisions many people are making with their own skin in the game. I guess another kind of application where real time seems to matter a lot is energy, kind of stored energy applications.
Yeah.
Because demand is changing all the time. That's dependent on factors that are both predictable and also essentially unpredictable, like the weather. And you guys work on problems like that too?
Yes, absolutely. And today, a lot of that is still processed in batch. They've had energy management, stuff like OMS and all this kind of stuff that could talk to smart meters that are basically connected to cell networks for many years now. However, mostly it gets collected into this system, and then after it gets collected in the system, it gets batch and analyzed.
So it's transmitted real time via the cell networks, but then it's just held and then analyzed batch later.
Yeah.
Right.
And how weird is that, right? So, and what it was is we didn't know what to do with it, and we didn't know all of the different things we could do with it, and we didn't have the incentive to do things with it. But as energy becomes a more and more precious commodity, and we have these different natural events and things that have happened, people are starting to look at this and say, okay, what if I really was handling the grid as a real-time entity? What if I was really looking at how are these, what are these meters doing? What do things look like at that level? And what should I be calling this customer up? It's not just, now there's some interesting regulations that come into place here, but it's not just that, but it's also how do we best use this data in a way that protects the grid, makes predictions about the state of things based on weather patterns, based on all that kind of stuff. From PV cells is a big one. So for the most part, excuse me, for the most part, PVs, solar panels, are not all metered directly.
Okay.
So the manufacturer rates them, and the rating is wrong. That's the only thing you're sure of. The rating is wrong. And you have a big fat tree in front of yours, so even if the rating was right, it's wrong. Or you live in a different weather zone where it's cloudier or different, or there's a mountain or something. We need to be able to see what the actual generation from the PVs is so that we can tell what its impact on the circuit is, and so we can tell our customers, here's your real savings. Even if you're not metering all of them, you can meter them in different weather zones and come up with a statistical average and guess what the total load is. Ultimately, they should all be metered, and we should be grabbing that data in real time, because even if the weather's one way, we don't know what specific cloud coverings might do and what have you. So we should,
or everything else.
Yeah, we should be doing all of this in real time, and I think things are moving in that direction. I know a lot of power companies are doing these pilot projects where they have a model grid where they've pulled together some of these technologies and are experimenting with them, and that's sort of the the future there is really looking at all the data, in real time, and making these sort of more algorithmic decisions. They've been doing that for years, just taking it up a level.
Now those are going to be kind of heuristic, because those are that like optimal resource allocation is a computationally hard problem. You're never going to get perfect, right?
Correct.
Heuristic, that means a lot of continuous refinement and iterative work on the empirical data, right?
Exactly. And we have the technology, we have the algorithms, and most of the libraries and things are now even open source. We have the ability to do these things today, where we didn't have simply the power, the network speed, everything, the cell networks. We didn't have that not that long ago. So we really are moving to that next stage where business can, regardless of the sector, whether it be finance, medical, power, retail, we can really do these things in real time, change our orders in real time, change the electrical supply in real time, do all these different decisions so that we can adapt faster, conserve resources, make use of new opportunities, adapt to a changing regulatory or competitive climate, handle public data and news. I mean, this stuff touches everything.
Now this is slightly, or we can finish up in a minute, but slightly orthogonal, but this is raising the question in my mind of, there's a little bit of fear, could be fear around streaming data, like specifically the idea, like in the case of, let's say, high frequency trading, the algorithm is moving and it's making decisions, or it's making orders, whatever, or allocating energy faster than you have this kind of batched human check going on, right? But you can build in like thresholds and things like that into your analytics to make sure that either doesn't happen or that people notice it before it gets out of control, right? Is that like a domain-specific problem, or are there general kinds of like data scientific approaches that?
Yeah. There are definitely general scientific or data science approaches to that. One of them you can actually check out on our website, montecarlo.mammothData.com. And actually, what's been proven is that these algorithms are better at it than humans, and they're a well understood one. So when it comes to risk analysis, liquidity risk, or what have you, that algorithm actually came from physics.
The Monte Carlo models.
Yeah. So that algorithm actually came from physics, and it's been proven to be more accurate than analysts. Now, are most of these things more accurate on a single transaction or a single thing? Maybe, maybe not. I mean, you can look for those things and say, aha, I outdid the computer. But did you outdo it over the long haul? It's sort of like did you beat the S&P 500 once,
right,
1 quarter, 10 quarters? How long did you do that before?
Probably not for that long.
Yeah. How long did you do that? Well, guess what? I can have a run of wins. I'm going to the IBM IBM Insight conference in Vegas, and I could have a run of wins, but statistically, I'm still going to lose.
Yeah, they do these studies.
I don't gamble for a reason.
No, they do these studies for all the analysts. Did you beat the S&P or like other ETFs and things? And the answer is usually no. Over a couple of years, you probably are not going to. Right?
Yeah. So what we've proven,
your macroeconomic or Monte Carlo statistical methods make a lot of sense.
Yeah, so what we've proven is that these algorithms are better at this than we are. Our time is better spent looking at the overall, rather than being the people that sit here and act like a computer and process data one by one. We're better off looking at the big picture, helping design the processes and the algorithms, and doing that. Whether it's finance, whether it's a mom and pop real estate shop, whether it's mortgage companies and things like that, or healthcare or whatever, we're better off making algorithmic decisions than doing it one by one. And I mean, what do you want to do with your life? Do you really want to do? I mean, to some degree, a lot of people are sort of the Excel spreadsheet version of like Eminem in 8 Mile, where all he does is like sit there and punch that button that puts the car mold down or whatever. The guy that sits here and does this. A lot of people are basically sophisticated versions of that. Is that what you want to do with your life?
Almost every time I use a spreadsheet, I'm like, if we had a specialized tool, I wouldn't have to spend the next 3 hours doing this spreadsheet, right? So,
and that's what part of it is. Okay, yes, we need these specialized tools. We need to implement algorithms for offer management and know your customer and money laundering and fraud and so on. But we also need to look at the overall process and the overall micro decision making and start to make that, evolving that, what we spend our time doing, rather than creating a series of one-offs. Okay, if it really only happens once, fine. But when it happens the third or fourth time, you really shouldn't think about, should I hire someone to handle these situations? You should be thinking, can I alter the process to handle these situations? That may involve hiring someone, but should I alter the process?
right.
What are the factors that go into that process? What go in that decision? Is this a special case algorithm where I should be running an algorithm to just do anti-money laundering in real time? Or is this a case where it's really just sort of a people-oriented process, like ask the sales guy to call the customer kind of thing? So, so we're really moving towards data-driven companies. This is the hot topic in the business community, data-driven. The next stage, or the right now, to most people, that means creating fancy dashboards.
Yeah.
And
graphics data-driven.
Totally important is self-serve. Totally important as a first stage of our evolution is making it so that the business people don't have to call IT just because they want to get this one little piece of data or do this one piece of analysis. That is super important. But that doesn't stop there. The next step is, what is that process? What did you do with it? What did you do with that dashboard or report? Why? And based on that, okay, you got the final copies from these people. What did you do? Why did you do that? Okay, you made a decision. Gee, if these two numbers are within 20%, our cash flow is good, the salesperson is at their max productivity rate, then split his territory, hire another salesperson.
There's a business rule.
Yeah. So you did something. We can codify that. So this is using stuff like Spark Streaming, using stuff like HBase to piecemeal these decisions out, using stuff like JBPM for business process modeling and management and kicking things off, using stuff like Drools to codify decisions or create DSLs or set up decision tables, and letting the data drive this process. Yes, people will be involved, people will audit it, but they'll audit it probably in batch, but they'll audit the report on a periodic basis. People will audit it, people will adapt the process, people will make major strategic decisions until we figure out how to make those a little more automated.
And then 5 steps later, we're all like mind spirits in the cloud somewhere. And
there you go.
Maximizing our intellect.
We're all just mind spirits in the cloud.
Yeah.
That'd be a great. I think the next DZone article, we're all mind spirits in the cloud.
Yes.
That'll get slashed out. That'll be really big on Reddit.
Yeah, exactly. No, we're not Ray Kurzweil. He's a genius. No, he has 57 patents. Yeah, that kind of thing. So I'd love to talk more about specific domains, but I think we're kind of out of time right now.
Sure.
But let's follow up on that a little bit later, actually.
All right.
Right. Is anything
Sounds
last
good.
message like you'd like to give for our readers to learn more or to test some of this themselves?
So check out mammoth-data.com. Also check out. We got like a great white paper on Spark that's people have been downloading. We've got this DZone persistence guide that's fairly popular.
Totally free.
And free. So is a Spark white paper. We also have some great demos. SparkNLP.mammoth-data.com if you want to see some of the cool stuff you can do with natural language processing using Spark in the healthcare sector, or MonteCarlo.mammoth-data.com if you want to look at liquidity risk in the finance sector. And be looking. Hey, if you be looking for talks from us, I'm giving one today at 4 on data-driven companies and how to move in that direction. So look for that. This is an exciting time for this technology, and it's an exciting time in the business world where we can now actually move in this direction. We have the technology, we have the means, and we have the motive.
Cool. Right. Thanks a lot, then.
Outstanding.